Hello, everybody. Today is Wednesday, and we are completing our last section of notes for our polynomial chapter. Yay! Okay, and we are going to be looking at grouping and factoring with 4 terms. Our agenda for today is we are completing, you are watching an agenda video, you have grouping notes video, and then you have a drag and drop activity that is on Google Classroom. Similar to what we've done, I've given you a problem and you have to find the matching sets of parentheses that are that polynomial factored out. So, a little bit of review before we dive in. This is honestly an explanation of this whole chapter. So what is factoring? Factoring is going to be breaking up that term into its factors. It's kind of like moving backwards from simplifying. We want to know what its origin is, what numbers or values were multiplied together to get an original number. We've looked at the greatest common factors, meaning, okay, I look at all my terms within my polynomial and I see, okay, can I divide that by a common factor? We've done difference of squares where I've had a subtraction sign and I can take the square root of both values. I factored trinomials where I identify, okay, what can I add together to equal my middle term, my b, and what can I multiply together to equal my c. For factoring trinomials in the ax squared plus bx plus c form, we've done a slip and slide to get our final product. And then finally, we're looking at today, what if we do not have trinomials or binomials? What if I have a polynomial? Meaning, what if I have 4 terms? If I have 4 terms, we use a technique called grouping. What you do is you end up kind of dividing your polynomial into sections and factoring those sections. So if I have a polynomial x cubed plus 7x squared plus 2x plus 14, I'm going to divide that polynomial or group it into 2 sections. So let me change my color. So I just split it right down the middle. After I split it down the middle, I factor out the greatest common factor from each binomial. So looking at our first half, I have x cubed plus 7x squared. I can divide both of those by x squared, so I'm going to factor out x squared, leaving me with x plus 7. For my second half of my polynomial, I see I have a 2 in common, so I'm going to divide both of those by 2 to give me 2 times x plus 7. If you notice, when I factored those out, what I'm left with is the same product. I both have x plus 7. So because both of those are the same, we can combine those to equal 1, and we take our leftover junk and combine it into a parentheses set. So we call that factoring out the common binomial. So that's x plus 7. So when I factor out x plus 7, it leaves me with x squared plus 2. So then my final answer is x squared plus 2 times x plus 7. That's it. So grouping is a little bit more of the greatest common factor. So let's look at some examples. I have x cubed plus 4x squared plus 8x plus 32. I'm going to divide my polynomial in half. All right, looking at my first half, what is my greatest common factor? Well, my coefficient is going to be 1. Now I'm looking at my variables. Let's see, I can divide both of those by x squared because both of them have x squared. So I'm going to pull out x squared, which leaves me x plus 4. All right, can I look at my second half? What can I divide both of those terms by? Well, it seems like I can divide both of those by 8. If I pull out 8, it leaves me x plus 4. I see x plus 4 is the same. So I'm going to factor out x plus 4, which leaves me with the leftover chunk of x squared plus 8. I'm going to check my final answer. So x times x squared gives me x cubed. 4 times x squared gives me plus 4x squared. X times 8 gives me 8x. And 4 times 8 gives me 32. Does that match my original answer? Yes, it does. All right, let's look at another example. Factor each polynomial. I have p5 minus 6p3 minus 2p squared plus 12. I'm going to take a drink of coffee real quick. Woo. Okay, first step, divide my polynomial in 2. Shoop. All right, looking at my first half, what is my greatest common factor? Ooh, hold on, wait, pause. I'm going to make my line right here. Okay, because it matters with that subtraction sign right there. So looking at my first half, my greatest common factor is going to be P3. So which leaves me with P2 minus 6. All right. Because I have this subtraction sign right here, okay, I know that's going to have to be included with what I factor. Why? Well, because I'm looking here at my product, or what I got for my first half. I have p squared minus 6. Well, looking at my second half, this is not a subtraction sign. So in order for me to get that a subtraction sign, I'm going to factor out a negative 2, leaving me with p squared minus 6. So factoring out that negative sign helps me change that sign to a negative. So now my parentheses sets are the same. I'm going to factor out the parentheses set, which leaves me with p3 or p cubed minus 2. I'm going to double check my answer, make sure I got it right. So it leaves me with p to the 5th minus 6p cubed minus p squared plus 12. Check. All right. One more example. What do I do if I have 2 variables? Well, we complete the same process. So I'm going to divide my polynomial in 2. Looking at my first half, it doesn't look like I can factor out any of my coefficients, but I can factor out x. So that would leave me with 2y plus 5 looking at my second half, it seems like I could factor out, oh, I see what I did here. Okay. Looking at my second half, it doesn't look like if anything I factor will equal the same term, right? Well, looking back at my original problem, what's my issue? It's not in order, right? We have to have our polynomials in order for us to factor. So I'm going to rearrange it. So my negative x squared comes to the front, leaving me with plus 5x plus 2xy minus 10y. Remember, alphabetical, then degree. All right, now I can factor. Whew, I was scared. I was scared there for a second. Now I'm going to divide in half. I'm going to pull out, I'll pull out x. I'm going to pull out negative x. Okay, just make it easy. So that leaves me with x minus 5 All right. Looking at my second half, what can I divide both those polynomials by? I can divide them both by 2y, leaving me with x minus 5. See how rearranging it to its proper order helps makes grouping a lot easier. All right, now I'm going to factor out my common binomial, which is x minus 5, leaving me with negative x plus 2y. Check. Let's double check. So negative x squared plus 5x plus 2xy minus 10y. There we have it, folks. Okay, so I know I kind of went through this a little bit quickly, but this is a skill we have done in the past. You should know how to factor with the greatest common factor. If you don't, maybe you need to go back and re-watch the notes video going over greatest common factor. All right, that's all I have for you today. Your homework assignment is going to be doing the drag and drop on Google Classroom. As always, let me know if you guys have any questions, okay?